Hello everyone. Today I'm going to show you how to do question 1 on the midterm. Okay, so the question is asking us, please identify the starting material, diene and dienophile that would be needed to make the Diels-Alder product shown below. So here we have our product, so we need to find the reactants. So first we start by identifying the diene with this characteristic double bond. And as you can already see that there is a ring structure going on, so it'll be really helpful if I numbered the rings. So starting from there, 1, 2, and continuing. So since it forms a continuous ring, we can already draw that, and that'll help us. And then now we can place the double bonds. Usually in the diene, if you see the double bond here in the product, that means your reactant double bonds are right there, because we're moving one of the double bonds into that position while we're doing the reaction. Okay, so that's like almost half of it. Oh, and I made a mistake. This area should this area should have an oxygen. Let me just redo that. It's very sad drawing. Oh, not there, right here. Okay, so, and then we can number the carbons again. And then the oxygen is on number 5, and then the 6th carbon is right there. And voila, that's the diene, and that's your answer to box 1A. Okay, now let's look at the dienophile, which is this right here. And the bonds I'm highlighting in blue are the added sigma bonds, so that's not going to be in either the diene or the dienophile in the reactant state. So let's start by drawing the double bond that's in all dienophiles. For them to be a dienophile, they need this double bond. And then we can go ahead and look at the pink substituents. They're both in cis, as in they're pointing in the same direction. So we want them to point in the same direction. And then at this carbon right here, there is a double bonded oxygen. So you can go ahead and draw that. And if you feel fancy today, you can also add the H, but I don't think it's necessary for all these drawings. But it doesn't hurt to be more precise. And that is your answer to 1B. Okay, so next we're gonna do 1C. So in the reaction below, major product is missing several substituents. Note that the stereochemistry of one substituent, and that is this one right here, is fixed and you cannot change it. Okay, so first of all, something that's missing right off the bat you can draw in is this double bond. And then we also want to find the location of the sigma bonds that are going to be created in the Diels-Alder product. So it starts from there to there, and then there's one over here. Okay, so then we can go on and highlight the substituents that we're supposed to be adding. So there's that and that, these ones. And there's also another one that I should highlight in a different color right here. Okay, so the yellow ones are all pointing away from the reaction, right? So they're all going to be in the same orientation. So it'll be either pointing towards us or away from us, all of them at the same time, because they're all pointing away. So since the oxygen group or the aldehyde group is depicted with dashes, which means it's pointing away from us, we want all of the yellow substituents to point away from us. So that's the methyl group on the dienophile. You don't have to put the CH3, but I like to do that just for clarity. And then we've got the ether group, which would be pointing away as well. O, and then CH3. Sorry, let me make that clear. And then we also have this one, CH3. And then there is also this, the green one, which isn't pointing in the same direction. So we want to depict that with a wedge, as in it's pointing towards us. Okay, is that it? Yeah, that's pretty much it. If you're feeling fancy again, you can add 2 more wedges to show hydrogens. It makes it clearer, but I feel like it also makes it messy. So it's up to you whether you think that's necessary. I don't think you're gonna lose marks for not having that. And that is your answer to 1C. And hopefully that gives you full marks.